My name is Matt Norton, and I am a senior engineer on the NetApp IT Cloud and Compute Services team. First, I will walk you through infrastructure as a service, including a look at our ServiceNow UI portal, as well as a high-level architecture. The CloudOne Portal UI is based on ServiceNow, so what you're looking at now is our instance of ServiceNow, and this is the main landing page for CloudOne. You see the top three components. We have DevOps, container as a service, and database as a service. All of those are container-based currently. At the bottom, you have infrastructure as a service, or IaaS for short, which is strictly VM-based. So why ServiceNow? ServiceNow provides a lot of data and intelligence about our company. Some of those are user detail around management structure, cost center information. ServiceNow provides an existing, easy way to use SSO so that users can use existing username and password to access the CloudOne portal. Everything that you can do in the portal, for example, provisioning a VM, creates a ServiceNow R item. So the R item leaves a nice paper trail. It allows us to do things like workflow approvals. As an example, if someone tries to provision a VM to Amazon, which incurs a very real cost to the company, there is an approval that must be received by the user's direct line manager. Once that approval is met, then the VM workflow actually kicks off and provisions the VM. Another example is a lot of the forms for things like submitting a load balancer or VM. As the user fills out the form, the drop-downs, logic is applied to present choices that make sense or enforce our own IT standards on what is being provisioned. As an example, when you provision a particular type of load balancer, let's say a web load balancer, when you select to deploy web, then different fields are presented after you make the selection. The form is essentially live and updates and enforces our logic and standards based on the user's selection, and ServiceNow does a really good job of that. So I will go ahead and click on the infrastructure as a service link. This is the main IaaS landing page. What we can currently provision are VMs to Amazon and on-prem are the environments currently supported. We can provision storage. We can provision storage as part of a VM provision, or we can provision it completely independently. We can provision a logical load balancer. Our on-prem solution for load balancers is F5. In the case of Amazon, it will be an ELB, either an ALB or an NLB, depending on the selections that the user makes. And we also have the sandbox option, which is a time-limited VM, 2 months is what we currently have, so that users can get in and do easy proof of concept without any pre-existing requirements. So typically, when a user comes in to provision a VM, they will have to select a ServiceNow application as part of that provision. In the case of Sandbox, that requirement is not there, and so there's really nothing stopping a user from getting in, getting a VM very quickly, and testing out what they need to test. All of the provision options, VM, load balancer, et cetera, that I mentioned are captured here under build. Under manage, we have day 2 operations. So I've already provisioned something, VM load balancer. Now I want to go back in and update it. I want to maybe resize it or power on, power off, et cetera. Those types of day 2 operations are captured here under manage. Under administrative, We have links to helpful ServiceNow KB articles that relate to CloudOne or CloudOne IaaS. Certain things are very common among users, like how do I get an SSH key, which is required as part of the VM provision form. Those things are captured here under administrative. And then order history. So this is actually very helpful for the paper trail that I mentioned earlier, where maybe you're on a team of several people working on a given application, and you want to see what other team members have done. Maybe they've provisioned other VMs for that application or load balancers, etc. You can easily come in here to the order history and click on the appropriate button to see if any of those actions or workflows have occurred. Let's go ahead and take an example of a VM provision just to show you what the form looks like and how things change as you make selections. So I'll click under Build Compute with Storage. The form for this particular action will be loaded. The very first question that we'll ask someone, regardless of what they're provisioning within IaaS, is what application is this for? So again, these are application CIs that already exist in our ServiceNow CMDB. You can select register a new application also, but this will redirect you to a form that is also hosted in ServiceNow that would be filled out and submitted for approval. That process is manual. It goes to an actual human. That person has to review the application and subsequently approve it. So that's a hurdle. The sandbox feature I mentioned earlier negates this necessity, so you can get in without an application and easily provision a VM with some restrictions. But typically, you would already have your VM or your application CI registered. You would come in, select existing, and then from the drop-down, you'll pick your application, whatever it may be. You also notice that ServiceNow picks up my name here as the requester or owner of the item to be provisioned. My default cost center is also loaded. Network accessibility. So this has to do with the network posture of the VM. Basically, is it DMZ or not? So we have two simple options, internal or external and internal, which is effectively a DMZ selection. We have landscape, your typical dev, test, stage, prod. Some of these selections will help determine the VM hostname, which is based on our standard, and you'll see that that will be automatically generated by ServiceNow here shortly. Component code, web app DB, very simple. We could add more if necessary. After I select the component code, you see that our VM hostname is automatically spit out. ServiceNow will automatically select the next available rolling number. So in this case, if VMW AKG app 01 and 02 already exist, it's automatically going to pull 03 for me. Cloud region, this is our target cloud. Is it on-prem or is it a hyperscaler? Currently, we support Amazon, specifically the Amazon US East 1 region. The selections you see here, the last two, MPC East and West, these are on-prem data centers. MPC East is our RTP data center in Research Triangle Park, North Carolina. MPC West is our data center in Hillsboro, Oregon. For each region, we have accompanying availability zones. In the case of on-prem, we really only have one AZ, but if I change my selection to Amazon, you'll see that we're supporting the US East 1A, 1B, and 1C AZs. There are actually about a dozen or so. 1A, 1B, and 1C are fairly arbitrary in our selection, but those are the ones that we're committed to supporting at this time. We could certainly add more later. Of course, your operating system type. At this time, we support Linux only. We'll be adding Windows support very soon. Your compute profile is simply the size, your vCPU and vMem. These, in the case of Amazon, do correspond to particular instance types. Operating system selection, at this time we support CentOS 7 and RHEL 7. And then, much like you would experience in Amazon, you have to select a public key. We use RSA format. So a user has to generate an SSH key, which we provide instruction on how to do. They are responsible for maintaining their key pair, especially their private key. We do not do that for them. The key that is entered here will be added to the authorized keys when the VM is selected for a local user we call cloud-user. So once the VM is provisioned, the user can SSH using their private key to the VM to get access. We can also provision storage. We support NFS or iSCSI at this time. We allow the user to select up to 4 volumes as part of the VM provision. You can go in and control some parts of the volume name. The gray boxes are static, they cannot be updated. White boxes are pre-populated with information, but they can be edited also. Mount point, this is the mount point within the operating system. Again, the user can come in here and change this to whatever they like. You will also notice that we have a cost here. This cost is based off 2 things: the compute profile selection, the size of the VM. If I change that, you'll see that the cost changes here. This is a monthly cost. And it's also based off the storage size. So we're charging currently 5 cents per gig. So if I increase the size, you'll see that the cost also increases. This gives a total cost, again, based off compute and storage, of $133.10 per month. Currently, for on-prem, this amount is strictly showback, which means that we present the price, but we're not actually charging that to a cost center yet. But that will be implemented in the next year or so. Right now, it's really more of a financial challenge than a technical challenge. In the case of Amazon, though, we also present a cost here, and that is actually charged back directly to the requester's cost center that they enter in the form here. That process has been in place for a long time. Internally, it's a little more challenging with legacy process, but eventually we will do full chargeback regardless of the cloud region that is selected. Once I select everything required to provision the VM, I would click Submit here, and an R item would be created, which is emailed to the user. And within 30 minutes or less, a VM will be spit out and a confirmation sent to the user. Once the VM is fully provisioned and a success message is received by the user, they can come back into the portal and go to the Manage section. Once you click on the Manage section, you would be presented with a list of VMs that you are the owner for. As an admin, my list is quite large, but if we look at a particular VM, we can see the additional day 2 options that are available. Once I select a VM, the basic information will come up. This is stored inside the ServiceNow CI for the VM. Have my host name, IP, data center, operating system information, and so on, including whether CMDB discovery happened successfully, the owner, cost center, etc. So let's take a look at what we can do here. At the top, we have some basic administrative functions like a power on, power off, reboot. We can also resize the VM to change profile size from A to B. And finally, we can also deprovision the server entirely. In the middle, we have an image section. We can create or delete an image. Depending on whether the VM is VMware based or Amazon EC2 based, what actually happens on a technical level is different. In the case of VMware, when you select to create an image, what we will do is power off the VM, create a VMware clone, and then power back up the original VM. In the case of Amazon EC2, we're actually taking a snapshot. At the bottom, we have volume on-tap operations. In this case, you can see that the VM currently has 4 volumes provisioned, 1 of which is iSCSI, 3 of which are NFS. You can see in the case of this particular volume that it has been decommissioned. It's still shown here, but it's not actually mounted on the VM anymore. In terms of storage operations, we can perform a mount or unmount. So this will actually mount or unmount the associated volume in the operating system. So if I were to select this first volume here and then select unmount, it will actually unmount the volume in the VM. It will not edit FS tab. That's not the way we designed it. So when the VM gets rebooted, they would come back. The volumes would come back. In addition, you can, of course, increase the size of the volume. This is not only an increase in on-tap of the volume size, it actually will also extend the file system inside Linux to realize the new space. You can add additional volumes if needed. And finally, you can deprovision a volume. If we take a look at the VM that we've provisioned inside the ServiceNow CMDB, we can look at the CIs that are created by the IaaS portal and the relationships between those CIs. This is the VM that we looked at earlier. You can see all the basic information. And if we scroll down to the relationship section, we can see the storage volumes that we created in the portal that are associated with the VM, and also the images that we created. If you look right here in the middle, these are the 4 volumes that were created. So they have CIs associated with the storage that are custom, and when a volume is added, the CI is created and related to the VM. Ditto, up here we have a CI, a custom CI that represents the image that we created for this particular VM. So if you create new images or remove images, then these relationships are removed accordingly. So the fact that we're creating different types of CIs and relating them here in the CMDB is very important for existing processes in terms of operational teams that have to support the portal. It's still easy to come into the CMDB tried and true tool and see the relationships and infrastructure that are out there. Let's move on and take a look at the high-level CloudOne IaaS architecture. What we have here on the left is your end user, typically an application owner or developer coming into the ServiceNow portal to do things, to provision things. The ServiceNow portal, once you actually click on OK and submit to do something, is making an API call behind the scenes to our current CMP platform, which is Red Hat CloudForms. So Red Hat CloudForms, acts as our state database. Within CloudForms, you can add multiple providers, which you see here in this first gray box. An example of a provider would be Microsoft Azure, VMware Virtual Center, in which case we have several virtual centers that are represented, Red Hat Ansible Tower, and Amazon EC2. The most important one that we have is Red Hat Ansible Tower, which is sort of quarterbacking most of the automation. Most of the automation and technical underpinnings are achieved via Ansible directly. There's a little bit that's done with CloudForms, but the majority is Ansible. We do plan on removing the CloudForms layer. It's, we've determined it's an unnecessary middleman. It's a very complex product. It doesn't give you much out of the box. And most of what we can achieve with CloudForms, we can do more cheaply, easier with Tower. So in the future, we will be removing the CloudForms layer. So Tower will talk directly to multiple infrastructure providers. In our case, that means ONTAP for storage, F5 for load balancer. Eventually, we will also offer object storage on NetApp Storage Grid. That's coming. And it also talks to Cisco ACI and Palo Alto firewalls. So why Ansible? Ansible, most vendors out there today offer some sort of Ansible support, usually in the form of existing modules that you can utilize. So most things can be done with Ansible. In some cases, it's, it can do exactly what we want to do, or certain things may be a little less flexible with Ansible than they would be with something like a PowerShell or Python custom script. So where we can use Ansible, and because we would like to gain the identity and desired statefulness of a configuration management tool like Ansible, we will use it. But in other cases where it's just not as flexible or it's much harder to do, we will use other tools. So right tool for the right job. All of the code that makes up our Ansible playbooks and other, we store in Azure DevOps. We previously had an on-prem GitLab repo, and about 6 months ago, we made the move to Azure DevOps. Everything in DevOps is still Git, so it's not a whole lot different, but it also brings to the table fairly sophisticated CI/CD pipeline capabilities. So for all of our workflows that are supported, we build a pipeline inside Azure DevOps to be able to test those workflows. So we make sure to test every single combination permutation. So for example, if we offer CentOS 7 and Rails 7, then we make sure to deploy those. We make sure to deploy one internal, one external to make sure that firewall rules and network traffic is flowing as expected. It's much easier to do with CI/CD pipelines than to have to manually test all the combinations that may be out there. Most of our DevOps pipelines are written in PowerShell. You don't have to write it in PowerShell, but that was our preferred tool of choice. We kick off the pipelines in two ways. One way, the simple way, is just weekly. We will run all the pipelines that we have that represent all the workflows that we have on a cron schedule. Right now, we're doing that on Sunday. The other way is through triggers. So we set up triggers for all the different playbook YAML files that we have in the Git repo. And so, for example, if you update a playbook that's associated with VMware provisioning, then and when you push the code, that change is seen and the pipeline associated with VM provision testing is kicked off. We watch the pipeline, we make sure that it runs successfully so that we know that the code changes that were recently made did not introduce any new issues. If there are issues, then the pipeline has failed and we see that notification, and then we can go in and look and say, hey, what happened? Was this this error related to the recent changes that we made? And if so, then we can easily roll back those changes.